Hi there! This video is about stoichiometry using molarity from the class Intro to Chemistry, and I'm Fred Oakes. In this video, we'll be reviewing molarity and then using molarity in a stoichiometry problem. Molarity is used when working with solutions, for example, salt water. It measures concentration. Molarity is moles per liter. M is equal to N over V. We'll be using that equation for the rest of this video. The chemical reaction we'll be using is HCl, hydrochloric acid, reacts with aluminum, a solid, to form hydrogen gas and aluminum chloride, an aqueous solution. So we have two solutions, so we're going to use molarity in it. The problem we'll use is if 150 milliliters of 2.66 molar hydrochloric acid is reacted with a large sheet of aluminum, how many milliliters of 3.00 molar AlCl3 is produced? Let's take the numbers out of that paragraph, the volume and molarity of the HCl, and the volume that's not known, and the molarity of the AlCl3. Now, how do we get from volume and molarity to volume and molarity? What do we use as the bridge from one to the other? Well, this is stoichiometry, so we'll be using moles. We'll take the volume and convert it to moles of hydrochloric acid. Then we'll take moles of hydrochloric acid and convert it to moles of AlCl3. And then finally, we'll take the moles of AlCl3 and go to volume. In other words, volume to moles to moles, moles to volume. Okay, let's get started with that first step. Step 1, turning volume into moles. We'll use the molarity equation. We'll have to rearrange it so we can get at the N, and then plug in the numbers. The molarity, 2.66 times, here we have to make a pause. The volume is in milliliters, and for molarity to work, it has to be in liters. We have to convert milliliters to liters by moving the decimal place 3 places to the left. Now we can put it in the problem, 2.66 times 0.1500, and we can come up with an answer, 0.3990 moles of HCl. Okay, step 1 done. Now let's move on to step 2, moles of one thing to moles of another. We'll use Fred's famous fudge factor to convert moles of HCl into moles of AlCl3. The power of this factor is we put the unit that we want to cancel on the bottom, and then we put the unit we want to go to on the top. Now the numbers come from the chemical coefficients of the chemical reaction. So the 6 from the HCl and the 2 from the AlCl3. Okay, we've got it set up. Now all we have to do is multiply and divide. The top is multiplied, the bottom is divide. In other words, 0.3990 times 2 divided by 6 gets us 0.1330 moles of AlCl3. Step 2, done. Moving on to step 3. Step 3 is moles to volume. Again, we're going to use the molarity equation. Now this next step can be tricky for some people. We're going to rearrange the molarity equation to get at V. So V is equal to N over M. Plugging in the numbers that we know, molarity on the bottom and moles on the top. Put it into our calculator and we get an answer, 0.0443 liters. Now check it out, molarity is in liters. So we have to convert to milliliters for this problem to be complete. We move the decimal place 3 places now to the right, so it's 44.3 milliliters. Great. And now we've completed step 3 and we've completed the problem. To summarize, we've gone from volume to moles, then moles to moles, and in this third step, moles back to volume. 44.3 milliliters of AlCl3.